Hello, welcome to this video. This is for Craig and Bodyburner. There's about 5 or 6 questions, so let's get going. This one is from summer 2021, paper 13, and obviously it's an enthalpy change one. Here we go. So we've got to somehow find out what's going on here, using this information. So we have to construct a Hess's cycle. So let's go. So that's cesium. Whoops, it's not 2 plus, is it? It's plus. Cesium plus gas. I'm just rewriting that equation for now. Gives me cesium bromide, solid. Now it says I'm going to hydrate this. So what that means is down here, I'm going to get cesium aqueous. All right, so that's going to form that. And I'm going to hydrate the bromide ion. And that's going to be aqueous as well. So that goes down as well like that. And I'm going to solvate this. I'm going to dissolve this in water. And when I dissolve this in water, I get cesium ions and bromide ions. So there's my Hess's triangle. Let me see. This is the one I want, delta H reaction. I'm going to call this delta H1 and this delta H2. Delta H reaction is down here and then up here. So it is delta H1 minus delta H2. Delta H1 is the hydration of the cesium, which is this number. So this is minus 276 plus the hydration of the bromide, which is minus 335. All of that is delta H1. All of that is this. Minus delta H2. Delta H2 is the solvation of cesium bromide. So it's minus plus 25.9. And if you add all of this up, I believe you get 636.9. So there is the answer to that one. Okay, hope that makes sense. If it doesn't, give me a shout. This one is a bit nasty. Let's have a look. Copper dissolves in nitric acid, producing a solution of copper 2 nitrate, water and nitrogen oxide. As the only products, how many moles of acid react with 3 moles of copper in the balanced equation? Oh, looks awful. Right, so start off with copper. We're going to react it with nitric acid. We're going to get copper nitrates. We're going to get water. And we're going to get NO, which is nitrogen 2 oxide. All right. Now, I can see one thing. I don't know if you can see this. But if we have two of these form those. And there's no oxidation change there. So the nitrate ions, 2 of them, are not going to be affected by the reaction. One of them, though, one of these nitrate ions is going to form the NO there. Okay, so the first thing I want to try and do is balance the equation. Okay, and I'll show you how I do it. I hope it makes sense. Okay, so I'm going to give myself a bit more room here. I'm going to say 2 of these, and 1 of them is over here like that. All right, so why am I doing this? Well, I'm separating the one that does something. This is going to go to this. And these 2 aren't going to do anything because I don't want to bother with those really. So I'm going to do that. 2 don't do anything and 1's going to do something. All right, now let me put my oxidation numbers here. Copper is obviously 0 here. And let me use a different color. Nice red. Copper is 0 here, and it's obviously plus 2 here. So copper goes from 0 to plus 2, so that's a change of plus 2. The nitrogen in this one that does something goes from, it's plus 5 here, it goes to plus 2 here. So that's a change of minus 3. Okay, now I'm ignoring these because these aren't doing anything. I'm only looking at this nitric acid. Now, obviously, the rise in oxidation numbers must equal the drop in oxidation numbers. So I've got to do something here. I've got to times this by 3 and times this one by 2 to get plus 6 here and minus 6 here. So if I times this one by 3, and nice color change of green. If I times this one by 3, I'm going to get 3 of those and 3 of those. That's plus 6. Now I want this one to go down by minus 6, and I have to times it by 2. So 2 of those is going to give me 2 of those. Okay, so now the number of coppers is 3, and at the moment we've got 2 nitric acids that change and 2 that don't change. Now, obviously, I've got 2 times 3, which is 6. So this has got to change to 6 now because this 6 didn't change. And there we are, we've balanced it. I don't know how many waters there are, but they don't ask for that. So the number, now I can recombine these, can't I? So with 3 moles of copper, it's going to react with 8 moles of nitric acid. So the answer for that one is D. That's a tricky one, for sure. All right. You're going to get one, though, in the exam, so you've got to learn how to do them, I'm afraid. Talking about tricky, this one is very tricky as well, which is good. I'm glad you're asking the hard questions these days. All right, so this you've just got to. Involves a mathematical trick. Okay, so we've got ethanol, which is C2H5OH. It's going to react with oxygen, and it's going to give me 2 carbon dioxides plus 3 waters. That's going to happen. And methanol is CH3OH. It's going to react with 1 oxygen. So I don't know how many oxygens, but it's going to give me 1 carbon dioxide and let's have a look, 2 waters. Okay, that's what we know about the combustion. Couldn't care less about this. Couldn't care less about this. I'm just looking for these coefficients. Excuse me, and how many of these we've got. All right. So now, what does that mean? Well, if I call this X here, so 2 carbon dioxides, if the number of moles of carbon dioxide is X, the number of moles of, sorry, let me start that again. Let's say the number of moles of carbon dioxide is 2X, all right? And the number of moles of water is 3X. I'm using the coefficients, as you can see. All right. Now, this one, the number of moles of carbon dioxide here, I'm going to call Y, because it's not going to be the same as X, is it? Because that's what we're trying to find out. And the number of moles of water, we're going to say 2Y. As you can see, I hope you can see, I'm using the coefficients. Okay, there's a 1 there, and there's a 2 there. All right, now we use these to create a simultaneous equation. We know that 2X plus Y is equal to 35. And we know that 3X plus 2Y is equal to 55. Okay, so we've got these 2 simultaneous equations. Now we're going to solve them simultaneously. So what am I going to do? I'm going to times the top one by 2. There and there. Get rid of that. All right, so this becomes 2. What was it? It was 2 already, wasn't it? Gosh. We're going to change this, and that becomes 4. This becomes 2, and this becomes 70. Now I'm going to take the bottom one from the top one, so that's minus. This becomes minus, and this is minus. So there you go. And basically, I'm getting rid of my y's, so I get x is equal to 15. Okay, and if x is equal to 15, let's put that 45. So y is equal to 5. Okay, so that means x is equal to 15. So this is 30, 2 x's, and this is 3 x's. So that is 45. All right. That's the contribution from the methanol to the final volumes up here. All right. And y, methanol is going to contribute 5 and 10. Okay, as you can see, 30 plus 5 gives us 35, and 45 plus 10 gives us 55, which are these numbers up here. All right, so we figured out 30 and 45 and 5 and 10. Okay, so if this is 30, okay, where are we now? This is going to be 15, isn't it? Yes, because it's 2x, and this is going to be just x because there's a 1 there. If this is 5 here, this is also going to be 5 as well, isn't it? So now we've got the molar ratio of methanol to ethanol is 3 to 1. That's a tricky one for sure. I think that's a tiny bit unfair because you have to know that little trick, don't you? Number 32, the equation shows the decomposition of 3 moles of an ion containing chromium in an acid solution. Which statements are correct? 1 mole of Cr043 minus is reduced. Well, let's have a look. This is minus 8, so the oxidation number of the chromium is plus 5. Okay, over here, -8 to -2. Here it's +6, and here it's +3. So what happened then? Well, one of them went there, and two of them went there. Okay, 1 mole is reduced. Yeah, 1 mole was reduced from +5 to +3, so that is correct. 2 moles are oxidized, +5 to +6. Yes, that is correct. 3 moles of electrons are transferred. No, that's not true, is it? Because going from +5 to +6, all right, there's 1 mole of electrons that were transferred there, because +5 to +6, it goes up. I'm not saying if it was given or taken away, but there's 1 mole of electrons there. But two of them were oxidized. So this is 1 mole times 2, because don't forget, two of these were oxidized. 1 mole was reduced, but that went from +5 to +3. So that involves 2 moles of electrons, because it was a change of 2 oxidation points. Okay, so that's 2 moles. So 3 moles of electrons are transferred. That's not true. There's 4 moles what were transferred. Okay, so that's the multiple choice part of the PowerPoint, not PowerPoint, the thing done. Let me look at the other bit now, and the other bit is a structure paper. Let me pause the video.